one more example. So I remember the general idea, but I'm going to use this cofactor formula for a matrix. So here's going to be my example. I promised in the lecture outline at the very beginning to do an example, and I'm going to pick tridiagonal matrix of ones. I'm drawing here the 4 by 4. So this will be the matrix. I could call that A4. But my real idea is to do n by n, to do them all. So everybody understands what A1 and A2 are. Yeah, maybe we should just do A1 and A2 and A3 just for this. So this is A4. What's the determinant of A1? What's the determinant of A1? So what's the matrix A1 in this formula? It's just got that. So the determinant is 1. What's the determinant of A2? So it's just got this 2 by 2, and its determinant is 0. And then the 3 by 3, can we see its determinant? Can you take the determinant of that 3 by 3? Well, that's not quite so obvious, at least not to me. Being 3 by 3, I don't know. So here's a good example. How would you do that 3 by 3 determinant? We've got like n factorial different ways. Well, 3 factorial. So we've got 6 ways. OK. I mean, one way to do it, actually the way I would probably do it, being 3 by 3, I would use the big formula. I would say I've got a 1 from that, I've got a 0 from that, I've got a 0 from that, a 0 from that. In this direction is a -1. In that direction is a -1. I believe the answer is -1. Would you do it another way? Here's another way to do it. Look, subtract row 3 from, I'm just looking at this 3 by 3. Everybody's looking at the 3 by 3. Subtract row 3 from row 2. Determinant doesn't change. So those become zeros. OK, now use the cofactor formula. How's that? If this was now zeros, and I'm looking at this 3 by 3, use the cofactor formula. Why not use the cofactor formula along that row? Because then I take that number times its cofactor. So I take this number, let me put a box around it, times its cofactor, which is the determinant of that and that, which is what? That 2 by 2 matrix has determinant 1. So what's the cofactor? What's the cofactor of this guy here? Looking just at this 3 by 3. The cofactor of that 1 is this determinant, which is 1 times negative. So that's why the answer came out -1. OK. So I did the 3 by 3. I don't know if we want to try the 4 by 4. Yeah, I guess that was the point of my example, of course, so I have to try it. Sorry, I'm in a good mood today, so you have to stand for all the bad jokes. OK, so what was the matrix? OK, now I'm ready for 4 by 4. Who wants to guess I don't know, frankly. This 4 by 4, what's the determinant? I plan to use cofactors. OK, let's use cofactors. The determinant of A4 is, OK, let's use cofactors of the first row. Those are easier. So I multiply this number, which is the convenient 1, times this determinant. So it's 1 times this 3 by 3 determinant. Now, do you recognize that matrix? It's A3. So it's 1 times the determinant of A3. Coming along this row, is a 1 times this determinant, and it goes with a plus, right? And then we have this 1, and what is its cofactor? Now I'm looking at this 3 by 3, this 3 by 3, so I'm looking at the 3 by 3 that I haven't x'd out. What is that? Oh, now it did a plus, or is it plus this determinant, this 3 by 3 determinant, or minus it? It's minus it, right? Because I'm starting in a 1, 2 position, and that's a minus. So I want minus this determinant, but these guys are x'd out. Okay, so I got a 3 by 3. Well, let's use cofactors again. Use cofactors of the column, because actually we could use cofactors of columns just as well as rows because the transpose rule. So I'll take this one, which is now sitting in the plus position, times its determinant. Oh, hell. Oh, yeah. I shouldn't have said hell because it's all right. Okay, 1 times the determinant. What is that matrix now that I'm taking this smaller one of? Oh, but there's a minus, right? The minus came from the fact that this was in the 1, 2 position, and that's odd. So this is a minus 1 times, and then this one is the upper left, and it's the 1, 1 position in its matrix, so plus. And what's this matrix here? Do you recognize that? That matrix is, yes, please say it, A2. And that's our formula for any case. A of any size, n, is equal to the determinant of a n minus 1. That's what came from taking the 1 in the upper corner, the first cofactor, minus the determinant of a n minus 2. What we discovered there is true for all n.